Howdy, howdy, welcome back. Today we're going to do something really cool. We are going to get YouTube controlled with our voice. And the way we're going to do that is with this device right here. Now this is a Google Coral. Now what this is, it's an edge TPU device, or it's a tensor processing unit. So essentially what it does is, you probably heard of CPU for your computer, so it's what does your general processing. Then you obviously have GPUs, which are for more graphics heavy, maybe some machine learning training or Bitcoin mining if that's what you've done, crypto mining, stuff like that. A TPU is specifically a edge processor that is meant to handle running inferences of ML models, machine learning models, really, really fast at the edge. The reason it's called the edge is it's not something that has to go bouncing to the cloud to process. So this means we can run all of this locally on our machine. We don't have to have anything being sent up to the internet to some server, processed and sent back. It's all just getting done on this device right here. So let's go ahead and dive in. And if we open up the Google Coral website, first thing we can do is let's go to their products. So Google Coral actually does quite a few other products. It's meant for either if you want to do a dev board, if you're familiar with, say, Raspberry Pi. This is kind of their version of that with the Coral TPU built in. It's also got, I think, like a quad-core regular CPU built in. Then they have a couple different profiles of just their edge TPU device that you could integrate into an existing product. So M.2 slots, pretty familiar with that. You can actually just get the little chip if you're going to actually design your own circuit board and solder it on there, which would be a cool project. They've got little mini dev boards that I haven't played with, but this USB device runs about $60, so really not bad. I bought a couple of these actually, but it plugs right in and you can actually do quite a few things with it. So what we're going to do is we're going to get this thing set up. I'm going to walk through some of the example projects they have, and we're going to get YouTube controlled with our voice. So let's jump right into it. So if I go to documentation, I'm going to hit the USB accelerator. Scroll down here. We're going to go ahead and get rolling with it. So I am running Linux. This is Ubuntu 20. I am in a virtual box, so it does work there. I had tried it with Ubuntu 22, which is my native system, and I had some issues with the lower install with the PyCoral library. Now, you are able to get around that, and you don't actually need it for some of the examples. You can build it yourself, but for simplicity's sake, I'm just sticking with Ubuntu 22, or Ubuntu 20, sorry. So let's go ahead and you can read through all the documentation about limitations, Python 3.6 to 3.9. I did get this to work with Python 3.10, but that was kind of a special use case and beyond the scope of this video. So first thing you do is go ahead and add the repo to your stuff. So if I go here, I've already done all this, so it should all be set up. Run that, and then add the sign key. Make sure it's all good. You can do update to tell your computer to get access to that repo, let it get informed. Then you should be able to install the runtime. So what this is actually the library that communicates with this device. So essentially like the driver that informs your computer how to communicate with this edge TPU. So let's go ahead and install that. Like I said, mine will already be here. One thing you're going to notice though is scrolling down, there's a couple different things you can do. You can do the STD one or the MAX or max version or standard. Standard is going to be a little more throttled. It's going to keep your device slightly underperformant, but also keep it cooler. I run the standard, and what you're going to see here is the performance from the standard library. I don't run the max because the max actually does heat up this device quite a bit. Like even the standard will get this device warm. So unless you have some additional cooling on this guy, maybe you've added some heat sinks or you've done more active cooling with a fan, I would not run it. You basically run the risk of damaging your device, and they say it right here. I haven't seen a performance hit that was needed for that. So once that's installed, which I've already got, the very next thing, all we got to do is go down here and we're going to install a PyCoral library. Now this is going to wrap TensorFlow Lite as well as some additional other features that are going to be needed for running the examples. So it's kind of a bigger install piece, and it's one that it's just for you to be aware that you're grabbing a few other things. That's how it's actually running, because the core model that this thing is kind of meant to run with is TensorFlow Lite models. Now, obviously, this device being a Google device, it's going to want to run a TensorFlow Lite model, given that TensorFlow Lite is coming out of Google as well. All of TensorFlow is. So I have seen people run other models on this, and I believe it's even in their documentation of how to maybe do some different libraries. But again, beyond what we're going to cover here, we're just going to run basic TensorFlow Lite. That's the machine learning model, or library rather, that I like to run on all my projects anyways, is TensorFlow. And then if I need to go lower hardware performance, I would go TensorFlow Lite. So all we're going to do is we're going to run this command line right here. We're just going to install Python PyCoral. I've already installed it. On your machine, it may take a couple minutes to get done. So hopefully that'll go through all smooth. And at that point, we are ready to actually run the model. It's a very, very simple little program. You can do the little test here for image detection, but what I want to show you right now is go through their examples. Cool, so now we're on their examples, and I want to talk about this for a second. The way the Coral works, or an edge TPU device works, it's taking a TensorFlow Lite model and it's just converting it over to say, hey, run on this hardware. In the same way that I could take a TensorFlow model and run it on a CPU, or I can choose to run it on a GPU. I'm just saying, hey, run on a TPU in this example. Now there's also an expansion of those kind of options when you get into the world of like FPGAs and things like that, and it gets really exciting. And you can do a lot of really fast inferences on dedicated hardware like this. It's the same thing if you've heard of like crypto mining and people are using ASICs, like dedicated hardware for crypto mining. Think of this as the ASIC of ML model inferences. So you're not training on this, you're just running the inference. But right here is a bunch of pre-done examples that will automatically run on this Coral. So you can do things like MoveNet, which is going to estimate human pose. Haven't played with that one, but that I have some ideas for a future project for that. That's going to be pretty cool. If you look at the segue video, this maybe will give you a hint to what I'm thinking to use with that. You can do, obviously, object tracking through video. You can also do some semantic analysis, as in grouping the actual pixels that correspond with an object, as opposed to just doing a bounding box. And then some other basic stuff like image classification or object classification, just the low-level basics. But the one I want to point out most is this key phrase detector. Cool, so when I click on that link, I'm actually going to get pulled to this GitHub repo. You can see this is a pretty old repo, but it's functional. These libraries still work, or these models still run. What this is this is a pre-trained speech-to-text model that actually works really, really well. If I go to the config, I can see it's pre-trained, I think, 148 keywords. I can look at what can I do, what can you do if you have a larger application you want to integrate this with. Simple things, yes, no for answers. You can do start game, start application. You can pause the game, volume up, volume down. These right here are going to be very important for our YouTube example. You've also got things if you want to integrate this into, say, a robot you control with your voice. You can say, move up, turn left, go forwards. All those are pre-built and they work really, really well. I was running this with, I've got like a $13 omnidirectional microphone from Amazon, and I was playing music in the background and it was still picking up these controls, or these commands. And yeah, so if we go back actually, they've got pre-written scripts for us. So we can see the main thing is run model. That's just going to do a basic detection. And they also have this run YouTube voice control. So that is actually what we're going to be running here to control YouTube. I want to show you something though real quick. So you can see right here, this is an example printout of running the model. And it's printing out all these audio devices, so microphone inputs. And it's going to say, hey, I'm using audio device default, which is index 19. Now let's say they had multiple audio inputs connected, or maybe default for your system is not the microphone you want to use. What you can do is you can actually see the IDs that's printing out here, and you can pass in an argument. So if I do Python 3, and I'm just inside of the Git repo that I cloned right here. It's just this on my actual system. Run model -h. I can pass in the argument --mic. And I can say equals, let's say I needed to use my this ID right here. I'd say 12. And that's all you should need to change the microphone input. For me, my default is the actual one I want to run. So if I go here and I just go make sure I've got my USB device turned on for this guy. Oh, well, I need to plug it in, obviously. And make sure my VM picked up that USB device. Okay, cool. So now that I've got the VM seeing my Coral, which is really the only issue I've seen running this system, is because I'm doing it through a VM. Sometimes the USB pass-through gets a little wonky. I've pulled up the actual words again so I can take a look. If I run this, hopefully it will load onto the actual Edge Coral. And look at that. It's saying, hey, I did not see anything, any words so far right here. We're seeing printed out. So it's saying 99% sure that I caught none of my keywords. But let's say, what can I say? Look at that. With 99% accuracy, it's figured out what I was saying. What about start game? Boom. All right, let's get a little crazy. Let's go backwards. Oh, so I got to go down for a second, but then I got to go backwards, and then it heard me saying it. If I say turn up, boom, look at that. So it's pretty darn good. It's not perfect. It'll have some misidentifications, but you can also limit that in their program. So you can say, hey, I've got all these options, and I only need like 3 of them. If that's the case, if you look at, say, their example with their V2, this is an example of the ones that you run for the YouTube control. You only have access to the volume up, volume down, next song, next video. And what that does is it helps eliminate false positives. As in, hey, I thought you said, what can I say? Well, even if it thought that, it's going to go look in this config right here and say, oh, wait, that's not a valid option for this use case. So I'm going to rule that out. So it really helps hone in on the accuracy of what you're actually using it for. I've done this for a robotic platform, and I just made my own little config and gave it the move forward, move back controls. And from there, I really eliminated most false positives. I actually haven't seen any, knock on wood, for that particular project. And it worked really well with, say, music playing, all that. So let's go ahead and take a look at how to actually control YouTube. So if I ls real quick, I can see there's this run YouTube voice control .py. You can also run this in the bash script if you're on the actual Coral dev board. But for us, we're going to run the Python. So let that run. And let's go ahead and jump over to this video. This is my video, KaiCAD parts. Okay, so I'm over here on my YouTube video. As long as I'm clicked on it, check this out. Play video.
But I'd have a table for every.
Stop video. Play video. Play video.
Go look at my schemas.
Mute. Now stop playing any sound. It's doing this. So as long as I'm actually clicked on the video, these controls will work. So you can see what I'm going to actually do here is I'll say mute.
There's one little
volume up.
So what I've got
volume
is
down.
a part ID, which
volume
is
down.
part ID I made
volume down.
A symbols column.
Volume down.
An NPN, and we're going to walk through
Pause video. Volume down. And you can see it's actually adjusting as long as I'm clicked on this. So here's where maybe this would be a really cool application. So you could throw it into a robotics platform, but if you've got YouTube like this running and you want to do voice control, all those people do the magic mirrors that they can do voice control now with this and actually have YouTube playing on their system with their voice, because a lot of those mirrors are in situations where you wouldn't want to be touching it, like they usually get put in the bathroom or something like that, and you wouldn't want wet hands touching the touchscreen. So that's one application for this. But the fact that this is done in 5 minutes, essentially, you can have this control, I think is really cool. And yeah, hopefully it's something that you can pull into maybe your project, you can think of how to do it, and you can build a lot more sophisticated of a model and run it on this. So anything you can train in TensorFlow and get running on a TensorFlow Lite, you should be able to get on this Edge TPU. There's a few caveats, but more or less that should work. So if you're an ML engineer and you are someone that actually has the ability to go train something like that and actually get the data set and do it exactly for your use case, you're going to get a lot better results. All this is an example of how to run super performant on the edge. This shouldn't be introducing any CPU load on your actual host system. This is all running on the edge device. I ran this on an embedded Linux device like a Raspberry Pi, and I did not see a CPU load jump. It's offloading all of that onto this device, which is probably the coolest thing ever. So now you can do really, really fast real-time inferences without internet. It's all on the edge device. So hopefully you found this pretty cool. I love this stuff. This is where I'm actually super passionate, is machine learning and how you can actually take something and make it practical for real life. So if you find that interesting and you like it, make sure you like and subscribe for the whole algorithm thing. But yeah, more videos coming, and this is definitely going to be a big part of some future videos. So alrighty, have a great one, y'all. Take care.